So I was looking for a way to define the current state of the Kubernetes community, and a three-ring circus sort of seemed like a good definition. So this is kind of what it looks like. I just was looking for pictures and things like that that would explain, but I think that elephant picture is a little inappropriate. That this one's better. So there's three real areas where I believe that the Kubernetes community is invested in at large. And I'm going to explain at how I came about to define it into these three buckets and these three things. So in the beginning, Kubernetes was a humble container orchestrator. We were all doing Docker builds, and then once the community started to do more than like 20, 30, 50, 100 containers or so, it started to become hard for people to manage. And then along came a container orchestrator that could do well. It had all of the bells and whistles that we regularly associate with any web application. And then monitoring was one such area. And then in the area of security, well, I think I'm guilty of not having done anything with regards to security to begin with. And then along came this new term in the industry many, many years ago about becoming cloud native. And what that meant was everything started to shift in the direction of becoming containerized, more optimal for use as containers or use with containers. And monitoring was no different. It also got subsumed into the cloud native sort of space. And well, security just became a marketing term at this point, and there really was no cloud native security efforts in the beginning. As days and weeks and months and years progressed, the cloud native landscape sort of blossomed. So I think everybody knows that huge CNCF picture with like a million different tiles, each of these things doing one different thing. And then monitoring also started to differ a little bit, and then it started to take on so much more than what it originally was. And then they started to emerge the first definitions of cloud native security. Things started to change in the platform space. People started to build differently, deploy in a way that was more in tune with how they did cloud native stuff. And the whole monitoring space took on this new form known as observability, where things started to become more in terms of let's understand what's on production, let's understand what's running, and then build some incident management and other efforts from that. And as this was happening, a log4j shell event happened, and even though we were very modern with the way we were doing builds and deployments and having shifted to observability and all of these new ways of knowing what's in the container, nobody was in a good position to predict an attack like that. And that really changed the whole ecosystem, and it brought about the emergence of what we now term as software supply chain security. And so many things started to happen in this space after that people could not keep up with all of the different things that were happening in these different areas. So that's why I'd like to summarize these developments into three significant buckets: what I term platform engineering, or what the industry terms platform engineering, what the industry terms as observability plus monitoring, so sort of a midway between the two, and the notion of cloud native security in the frame of software supply chain security. So welcome everybody to my talk at KCD Kochi. My name is Ram Iyengar. I'm the Chief Evangelist at Cloud Foundry Foundation. I'm here, like I mentioned, to talk about three major areas. A, platform engineering. I promise my slides won't be as confusing as those first 15. B, we're going to talk a little bit about observability, especially as it pertains to the Kubernetes space. And finally, I want to talk about security and certain aspects of Kubernetes security that I feel are important for this audience. Platform engineering, once you get rid of all of the marketing hype around all of the different pieces, is essentially three pieces. So there's how you build your application, or how you create your containers that are going to get deployed. So there is deployment, which is the second sort of part of platform engineering. And finally, there is how you keep it in operation and how you maintain the application in production. Observability is largely subsumed by what is known as the OTel, or the Open Telemetry Project. If you've not heard about it, or if you're not familiar with it, I highly suggest and recommend that you familiarize with yourselves. And I'll go through some of the basics during the talk about what this is and what it can be for engineering teams. And finally, security, like I mentioned, is largely subsumed by this notion of the supply chain security. So in the world of open source, you have what is known as provenance. So you have to be able to necessarily specify and verify at runtime where a particular container or where a particular image layer came from. We're all developers here. We have no shame in admitting that one day we are stuck with a problem. We'll go on to Stack Overflow, query for some error message, grab a few lines of code from there, just stuff it. Now my code works. I'm very happy. You can't tell for sure if that's a real code or if there's some typo squatting stuff hidden somewhere in there. And so it can become very difficult for engineering teams to identify where particular code or where particular images came from and stuff like that. And so security today has expanded from the realm of just application hardening to also making sure that people know exactly where certain images that are going into the larger container that they're going to deploy are actually coming from. And so security has shifted realms, I would say. And it's important to keep note of these aspects of software security as well as you start to build your security practice. All right. So now let's talk about the first thing. My favorite one of them all, platform. No, I'm lying. I actually enjoy talking about all three. And platforms really are abstractions. So they're abstractions in waiting. I know abstractions can be a little difficult to digest as engineers. So you might start to argue, is it a long tail? Is it a leaky abstraction or what have you? But abstractions in the sense that you have the ability to provide a uniform interface to a Kubernetes cluster for a large number of different workloads that can be put on there. So that's what I really mean by taking this notion of a long tail to a really long tail. So there's so many different things that a developer might come up with or an engineering team might come up with, and you will be sort of forced, in a manner of speaking, to provide support for these on your platforms or using the platforms. And what complicates this is it's always a multi-X approach, as I like to call it, which means that you're either having to deploy to multiple cloud providers, or you're going to have to support multiple different languages and frameworks, or you might have different teams writing different databases and things like that. So this sort of comes from the culture of microservices that people have decided to adopt, all along. And obviously with all of the agility benefits it brings, it also brings the challenge that no two teams' footprint is the same. And so when you're talking about providing a uniform interface, you have to keep in mind so many different things that need to be supported and things like that. And the important aspect of platforms, especially in the era of Kubernetes, is they need to build from source. So we are all quite well aware of these infrastructure as code patterns and everything as code patterns. And so your application, your infrastructure, and now everything in the middle is defined in code declaratively, and those get managed by the platform itself. And so the platform really needs to be capable of building from source, so to say. And then after the build comes deployment. And deployments are obviously automated. We live in the era of cutting edge CI/CD. I don't want to get into the nitty-gritty of all of that. I'm sure that a lot of you have your favorite CI/CD tools. I know one tool that I don't like. I'm not going to mention it, but it's very opinionated. People have their own likes and dislikes vis-a-vis CI/CD tools, and platform efforts have to take into account CI/CD tools and have to work those into the natural workflow of the platform itself. Otherwise, you're going to look at alienating a lot of engineering efforts that have a particular opinionated way in which they like to work with CI/CD. Finally, orchestration is like the big piece of the platform. Fortunately for us, Kubernetes is an orchestration first tool. So it does so much more today than just orchestration, what it was designed for. But the entire notion of container orchestration is baked right into Kubernetes. And so any platform engineering effort that happens sort of subsumes the ability to orchestrate as well. I mean, just in this previous demo, we saw Karthikeyan do kubectl followed by record inserts into a database. That has nothing to do with container orchestration, but Kubernetes as a community has been so broad in its support for all of the different things that you can do. And there's a few wonderful talks about what all Kubernetes has mutated into than just being an orchestrator. But like I mentioned, any sort of platform efforts subsume the orchestration piece within itself. This is a link to, this is a QR that you can scan, which will give you access to a platform's tag. So there's a tag app delivery inside the CNCF, and they have published a platform white paper. So this will give you access to that. If you're interested, do check it out. Now, the second part, like I mentioned, is observability. And observability can be very fancy thing or a very simple thing, depending on which part of the DevOps spectrum you sit on. It really refers to the ability of understanding the state of a system, and Kubernetes-based applications can be extremely complex. I mean, everybody here will agree with me that it's not easy to keep tabs on all of the different pieces, but observability is the notion of being able to look at certain symptomatic aspects of the entire system and provide a lot of the information that engineering teams require in order to keep this running. So observability in the Kubernetes world is largely a function of the OpenTelemetry group. Now, OpenTelemetry was formed from combining two different groups. So there was OpenCensus and there was Open Tracing, and both of these were focused on like slightly different areas. So if you followed along in the evolution in the first few slides, OpenCensus was all about metrics, logs, and traces. Open Tracing came along and just wanted to do application tracing and distributed tracing and things like that. And so it didn't make sense to have these two independent projects. And so in the year 2020, I think, around the COVID time, these two projects were sort of merged into one, and OpenTelemetry emerged from that. OpenTelemetry's first release was in 2021. In the past couple of years, OpenTelemetry has really taken off. So there's a large swathe of projects. So if you recognize Prometheus, Grafana, and all of these other tools, you probably recognize some of the more popular OTel projects. The nature of OTel is divided into an OpenTelemetry protocol, which sort of governs everything else. There's the OpenTelemetry API that all of these different projects wanting to be a part of the OTel working group have to implement. And then there's agents, collectors, and some SDKs that are available that are language specific. Now, this picture will give you some idea of what the architecture is and how you can make use of different OTel components inside your specific architecture. The modular design of this entire thing allows you to swap components in and out. So if you have very specific needs, OTel is very convenient in terms of being able to provide those layers and those building blocks that you can make use of for a very bespoke or custom architecture. I will also give you a link to an OTel white paper. Now, the last update to this was around Chicago would be my guess. So it's fairly current, but I haven't seen a lot of activity on this happen since then. So again, if you're interested in sort of learning about OpenTelemetry, what it can and cannot do, and how you can take advantage of it as engineering organizations, I highly recommend scanning the code and sort of learning a little more about it. Now my last piece, and obviously you save the best for last, is about security. And I remember going to a circus as a kid, and the guy who puts his head inside the lion's mouth will come around the end, and security is sort of that. And security in the cloud native world is defined in terms of these 2 or 3 different stages, like we saw for platforms. So granted that you would expect as an engineering team that security would be a part of platform, well-architected platforms, which is good. There's also a few additional notions of security that as people working with Kubernetes and as people invested in the cloud native ecosystem, I have an opinion that you should follow. Now you might find my approach is right or wrong or too much or too little. I'm happy to take any feedback about it. But essentially it is about the notion of who has access and what do they have access to, which sort of forms the basis for how security is thought of in the entire Kubernetes space. Now, earlier, a lot of the talk about cloud native security was about these 4 C's approach. So you have cloud infrastructure, and you have the container on the other end, and then in the middle you have the cluster that it's running on and how to secure the cluster. And over and above all this, whatever went inside the container in terms of the code that was actually built into the application was really the 4th C. So cloud infrastructure, clusters, the Kubernetes clusters themselves, containers or images that are built and deployed, and then the code that actually gets transformed into these images. So these were the 4 C's that people famously spoke about when they spoke about container security, and that has been shifting to a slightly different model. Now, about 30 years ago, this principle called zero trust architecture was first proposed in some PhD, dissertation, what have you, right? Obviously where ideas go to die. But since then, a lot of interest has emerged in zero trust architecture, and about 10 years ago, there was a bunch of different people at Gartner, at NIST, at various other fancy agencies who decided to come together, make this a thing, brought out all of those principles and things like that, which today is very useful for the cloud native community to piggyback on. So the principle behind zero trust is never trust, always verify. So that sort of summarizes their entire approach to security. Again, this is slightly outside the realm of application hardening itself. These are all principles and protocols that are put in place. Zero trust is extremely identity centric, so they want to assign an identity to everything that's part of a cloud native workload. One of the things that they try to do is they try to assign an identity to workloads themselves. So you heard of IDs being assigned to infrastructure. You've heard of IDs being assigned to hosts, for example, an IP address, right? So there's no notion of an ID for a workload itself, and SPIFFE is a CNCF project aiming to change that. SPIFFE stands for something, go check it online. I'm not going to worry about it, but the idea is you introduce this notion of an ID or an SVID for workloads themselves that SPIFFE can then make use of and put out. SPIFFE IDs are like URLs, but like I said, these are identity documents for workloads themselves. SPIFFE, remember, SPIFFE is a specification, and one of the implementations of SPIFFE is Spire. Another CNCF project, again, fully open source. You can check out their implementation online and work with it. So Spire actually does the job of being an agent, assign these IDs and verify these IDs on demand. So Spire is the implementation. It was built on SPIFFE. So it's basically SPIFFE runtime environment, and it has like an agent-based architecture that you can make use of. The other project that I wanted to throw some emphasis on vis-a-vis security is the ability to sign images and provide provenance. Now, provenance is a definition which is thrown around a lot, but it basically aims to say what your project or your image actually contains, and if that image can be trusted from a particular source, and if that image was built in a secure environment. So it answers a few of these very interesting questions, and one of the projects that's technically not a part of the CNCF but is used by the CNCF community a lot is Sigstore. So do check it out. It provides a way to sign images, and when you have policy and other things, for example, there's a project called Kyverno, part of the CNCF, and Kyverno can verify Sigstore-based signed images during runtime on your Kubernetes cluster. So it's a very useful tool to have, whether or not you're using it to sign images themselves. You can take a look at it and see how it better integrates into your entire workflow. Again, we're just skimming along the surface here. This is a code you can get access to, a CNCF security white paper. So there's tag security within the CNCF, and tag security has a white paper, very current. I know like a bunch of different contributors who've made some very recent contributions. So if you want to take advantage of security for your clusters, which I think you should, especially in the wake of so many different kinds of attacks, do check it out. They have a few reference architectures, they have a few recommended best practices and things like that, which you can make use of. In conclusion, my big message is, we're all open source. No, in keeping with the theme of the three-ringed circus, consume all of these projects, try it out, give feedback. There's a whole community waiting to hear from you. You might be at the beginning stages of your cloud native journey, doesn't matter. You might be very experienced. It's very welcome. And so start to consume these projects, make use of them, see if you can identify some use cases where you can put them to good use. Contribute back. They're all open. They're all available for you to work together and get some mentorship and do something. And if you can, in the long term, help maintain them. It'll be really wonderful if some people from this community and this audience, or if you're watching this on YouTube a year later, can come together and throw some contributions in and continue to maintain them. That's my talk. I'm Ram Iyengar on most social media. Do give me a follow. Do connect if you're interested in chatting about this further. I'll also give a small shout out to a panel that we're going to do later today, right after lunch. So stick along and be here for that session as well if you're interested in exploring some of these topics further. But thank you so much for being here. Thank you KCD Kerala for having me, and have a great day.
That was a wonderful session. Thank you so much.